Okay, let's continue to the lecture. So currently we get ordered sequence, and we also have we recorded the first element of unsorted sequence, right? So next we will continue back to the while loop, back to this line, right? And the current is also not non-pointer, so we will get inside of the while loop. We will go to this line. We need to create a next to record the current is next, right? Current next should be 6, this one. So the sorted is not equal to non-pointer, right? So we will trigger is not and the sorted data, this one is not greater than the current data. So we will just jump to the else to this line. And we need to create a template to record all the elements of the sequence. So the template is equal with the sorted, this one. The template is a deep copy of the sorted, right? And also the template next is not non-pointer, but the template next data, this one, 12, is not less than the current data, right? So we will not trigger this condition. We'll just skip the while loop, go to this line. The current is next. This one's next should be the 6, right? Will become the template next. This one's next. This one, right? Because the template is equal with the sorted. So the current will point to the 12. And then we set the template is next. This one's next. Also, this one's next will become to the current. So it will have 2 pointer. No, just one. It will have the point to the current. And then we set the current will become the next. This one. Current become to the next, right? In previous next is 6. We change the next to the current, right? So continue back to this line. Also, the current is not non-pointer. We will continue the while loop. So in this line, the next will become, we will create a new next will equal to current's next. And the next should be the 13, right? So that is the next. And then the sorted is equal to non-pointer. No, it's not equal, right? And the sorted, the data, this one is greater than the current. That's right. The 8 is greater than the 6. So we'll trigger this if. We jump to this line, and the current is next. This one is next. It will become to the sorted. That is what the head insertion do. The current is next will just point to the sorted. And also the change is the sorted becomes the current. In this line, here will become to the new sorted. And then the current will become to the next. Here, the current will become to current. So in this step, we get a new sorted sequence. It have 4 elements. So the rest of unsorted sequence only have 2 elements, this one and this one, right? So let's continue the while loop. In here, also the current is not non-point, right? So let's go to this line. The next will become to the current next. It should be the 7, right? And then sorted is not non-pointer, and sorted data is greater than current. No, it's not greater than the current data. So it will jump to the else, jump to this line. We need to traverse all the elements of a sorted sequence and compare with the current to make sure which position is correct for the 13, because we need to insert into the sorted sequence, right? So we create a new one, which from the head of sequence. And then we get into we back to the while loop to make sure the next data, this one, is less than the current. If it's less than, we continue to traversal all the elements of, continue to traversal the elements of sorted sequence. Here, the template will become the next, will become to 8, right? And back to while loop, it's still, the 8 is still less than the current. So we will continue to traversal. The template will become the next one, will become to the 11. 11 still less than 13. So we will continue to traversal again and again until in this step, the template becomes to the last element of sorted sequence. And when we back to the while loop, the template next is equal to is not equal to the non-pointer, right? It is equal, actually it is equal to the non-pointer. So we will not satisfy the condition. So it will break the while loop. We will jump to this line here, right? And the current next will become the template next. That is very similar with the tail insertion, but it also have some different, but never mind. And then the template next, this one's next, will point to the current. So in this way, we insert the current into the tail of the sorted sequence, right? And then we change the next to the current, right? So in this step, we only have one element haven't sorted yet. And in next step, the next will become the current is next. It actually a non-pointer because there's no elements, right? So the sorted still not non-pointer, and the sorted data is not greater than current state. Current is 7, the sorted is 6. So we will jump to this line. We need to traversal all the elements of sorted sequence, right? So we create a new one, create a template, which is deep copy with sorted. And template next is not a non-pointer, and template next data is not less than the current data. Because the current next data is this one, right? Because the 6 is equal to this one. The 8 is not less than the current, so we need to break it's not satisfy the while loop, so we just to jump into this line. The current data will become to the template next. The current next will become the template next. So here, he will point to the 8, right? Also, the template next will become to the current. So in this way, we successfully insert the current, the 7, into the correct position. So finally, current is become to non-pointer. When we back to the while, the current will become is actually the non-pointer. So we will just break the big while loop. We just jump to the last line. The head will become the sorted. Here, the sorted will become to the head, right? So we in this process we get a new sequence which is sorted, right? So next we will talk about how using the double linked list to achieve the insertion sort. First, we need to judgment also if the sequence is not empty and is also at least have 2 elements. Because if the head next is a non-pointer, that means the sequence only have 1 element, right? So we need to create a new uh create a new node, the sorted, which is equal to the head is next equal to the 8, right? And then if sorted is not non-pointer, we need to create a key. The key was like the role of the key, it was like a template in the previous, but it is also have some difference. Never mind. Here we also create a previous node to record the previous one. It should be equal with the sorted is previous. It should equal to the 12, right? And then the sorted will become to the sorted is next. It will become to 11. I know in this step, until this step, it's hard to understand, but don't worry. In the next process, you will clearly understand what's the code to do, what is the code done. Okay. And then the previous node is not non-pointer, right? And the previous data, the 12 is greater than the key. Actually, we can using the sorted, we can use the previous node in the current step to represent the sorted sequence, and the 8 should be the template we traversal from the first element over the unsorted sequence, right? So we compare the 12 with the 8, and the previous node, the data, the 12 is greater than the case data, so we will jump inside of a while loop. So the previous next data, previous one, his next is 8. This one's data will become previous one's data. So the 8 will become to 12. And then the previous node will become previous one's previous. This one's previous is non-pointer, right? So it will become to non-pointer. And then because the condition will not be satisfied, so that's why we will quit from the while loop. We just jumped into this line. The previous node is not non-pointer. No, it actually is a non-pointer, right? Right, it's a non-pointer. So we'll go to this line. The headers data will become the case data. So that makes sense. So in this process, the key was like a template to record the element, and the previous one should record the head over the sorted sequence, and the sorted will record the element needed to compare in next time step. So we back to the while condition. The sorted, this one is still not non-pointer because we haven't traversed all the elements of unsorted sequence. So we will trigger this condition. We will get to this line. The key will become sorted. The key need to become to record which element needed to compare in this time step, and sorted to record the next element needed to compare in the next time step. Here, the previous one will become to the sorted previous. Sorted is 11. Its previous is 12, right? Actually, we can regard the 8 and 12, these two elements, as a sorted sequence. So the previous nodes actually record the last element of the sorted sequence, right? And then the sorted will become sorted next. That makes sense because it records the next element needed to compare in the next time step. And then the previous node is not non-pointer, right? And the previous node's data, the 12, is also greater than the key. So in this time step, what we done is just compare the current time step's element needed to the element it needed to compare. We compare with the last element of the sorted sequence. That is this one, the 12. Because if we're using the single linked list, we need to compare from the first one and traverse all the elements to the last one. But if we're using the double linked list, we can just very convenient to compare with the last one. We compare the 11 with the 12. And also the previous one, the 11 is greater than the 12. So we need to jump to this line. The previous next data, this one, the next data, that's the 11 will become to the previous data. So the 11 will change it to the 12. It was like to put the 11, this one, to the next position and insert the current element in between over I mean in the before the 12, right? So the previous node will become previous node's previous will become to 8, right? Because if the 8 is still greater than the key, maybe if the 8 become to the 11.5, 11.5 still greater than the key, we will continue to traverse to the last one of sequence. That means we will traverse from the last one to the head one, to traverse one by one until the previous node is less than the previous node is less than the key, the current time steps element. So we set the previous node will become to previous node's previous will become the 8. So in this time step, when we back to the while loop, the key is actually greater than the previous node. So we will quit from the while loop and jump to the if. And the previous node is not non-pointer, right? So we will just jump to the else. And the previous next data, this one next data will become to the key. That makes sense, right? So in this process, we compare the key, the current timestamp element from the tail of a sorted sequence from the 12 and to the head one by one, compare this one and compare this one. And we find the 11 is greater than the 8, so it should be inserted in next over the 8, right? So after that, we actually get there is a mistake. We have 3 sorted elements. The 12 also should be green, but never mind. And the sorted is still not non-pointer, so we go to this line. The node's key is sorted, becomes sorted. So here it will become to 6. This also makes sense because do you remember the key is record the elements in this time step needed to compare, and in the next time step, in the next line, the previous will become the sorted previous. The sorted previous should be non-pointer. No. Sorted this one is previous will become the 12, right? And the sorted will become sorted next because the sorted record is the element in next time step needed to compare, right? So we go to this line. Previous is not non-pointer and the previous data. A 12 is greater than the case data because again we compare from the tail of all the sorted sequence, and 11 is greater than 6. So we need to set the previous next data will become to previous data. It was like we shuffle the 12 from left to right, right? And then we set previous nodes is become to previous nodes previous. It will become to 11. So in that next time step, we needed to compare 6 and 11. That makes sense. And then also the previous greater than the 6. So we will continue, go to this line. And also the previous next, this one will become previous data. Also, we shuffle the 11 from left to right, right? And then we set the previous nodes become to previous will become to 8. And then the 8 also greater than the 6. So we back this line again. And we also to shuffle the not shuffle, to buffer. Sorry, I using a wrong word. It just to transfer. I mean, transfer the 8 from left to right. Here should be become the 8, right? And then the previous node will become previous will become non-pointer. So when we back to this line, the previous is equal to non-pointer. So we will just skip the while loop into this line. Previous is equal to non-pointer. That's we just need to using a head insertion to insert the key. The head is data. This one's data will become the key's data. Just insert into here. So in this process, what do we do? Just to compare the 6 from the last one to the first one. When the element is greater than key, we just buffer. I mean, the transfer from the left to the right, right? So we in this step we transfer all the elements of a sequence from left to right, just one step, and insert the key into the header, and set the header equal to the key, right? And then let's back to the while loop. Sorted still not a non-pointer. So in this time step, we need to compare the 13 with the sorted sequence, and the key becomes sorted, right? Because the key is currently element needed to compare, and the previous become to sorted previous. It should become the 12 because it represents the last element of sorted sequence. And the sorted will become sorted the next. That makes sense, right? Because it represents the next time step needed to compare the element. Okay, the previous node is not non-pointer, and the previous one is not greater than case data. So we will just skip the while loop, jump to here. But the previous node also not non-pointer, so we will jump to the else. The previous next is very simple, just to insert the previous next. This one's next will become to the key, right? Very simple. And again, the next is similar with the previous time step. We traversal and set the previous next equal to the keys data will become to this one. So finally, that's all the process of a double linked list insertion sort. So that's all for class today. So in tomorrow, I will also post a video talk about how using circular linked list and how to achieve the selection sort. And if I have time, I will also talk about the stack and the queue. So when I finish all the part, I will also give you the pseudocode for your convenience, because you need to take a cheat sheet for exam, right? So I think that's all for today's video.